Hello and welcome. Today, we are going to explore the concept of memory allocation, specifically focusing on contiguous memory allocation strategies. Let's dive in. Contiguous memory allocation involves dividing memory into fixed-size partitions. Each process is allocated contiguous memory blocks. Memory utilization depends on the allocation strategy used. Processes must fit entirely in available partitions. A common challenge faced here is external fragmentation. We'll explore each of these points in more detail. Let's explore the three primary approaches to allocate memory to processes when using contiguous memory allocation: first fit, best fit, and worst fit. Let's start with the first fit algorithm. The first fit algorithm allocates the first available memory block that is large enough to accommodate the process. It scans memory from the beginning and stops at the first suitable hole it finds. It offers a fast allocation time and a simple implementation. However, it can lead to fragmentation near the start of memory. Here is the code for the first fit implementation in the C language. In this code, we iterate through the block sizes and process sizes and assign the first suitable block to the process. Now let's discuss the best fit algorithm. Best fit allocates the smallest available memory block that is large enough to accommodate the process. It searches the entire memory list to find the smallest suitable hole, thus minimizing wasted space. However, this approach creates very small fragments. Here's a visualization. If we have multiple memory blocks of varying sizes and a process that requires 30 megabytes, the best fit algorithm will allocate the process to the 35 megabytes block, as it is the smallest block that can accommodate the process. Now let's explore the worst fit algorithm. The worst fit algorithm allocates the largest available memory block for the process. It searches the entire memory list to find the largest suitable hole, leaving larger leftover fragments. This may perform better with many small allocations. Here's a visualization of the worst fit algorithm. If a process of 30 megabytes arrives and needs to be allocated, it will be allocated to the 50 megabytes block, which is the largest block available, resulting in a larger fragment of 20 megabytes. Let's compare the different allocation strategies. In terms of speed, first fit is the fastest, while best fit and worst fit have moderate speeds. Regarding memory utilization, best fit provides good utilization, first fit offers moderate utilization, and worst fit results in poor utilization. First fit causes medium fragmentation near the start of memory, best fit leads to small, often unusable fragments, and worst fit leaves larger, more usable fragments. First fit has a simple implementation, whereas best fit and worst fit have complex implementations, requiring a full search of the memory. First fit is best for general-purpose, balanced workloads, best fit is suitable for memory-constrained systems, and worst fit is useful for scenarios with many small allocations. Remember that the performance characteristics may vary based on specific workload patterns and memory availability. Let's consider some challenges in contiguous memory allocation. A significant challenge is external fragmentation, which refers to unusable small memory blocks between allocated regions. Internal fragmentation, which is wasted space within allocated blocks, is another issue. Processes may need to be moved in memory, leading to the challenge of relocation. Memory compaction, which is the process of reorganizing memory, introduces overhead. Additionally, there's a limitation on process size, as a process cannot exceed available contiguous space. Let's look at an example of external fragmentation. Initially, we have three processes: process 1, process 2, and process 3 allocated in memory, leaving some free space at the end. After process 2 exits, a 30 megabytes block of memory becomes free. Now, a new process, process 4, requires 40 megabytes of memory. However, it cannot be allocated, despite there being a total of 55 megabytes of free space available, because the free space is not contiguous. In summary, first fit is the fastest but can cause fragmentation near the start. Best fit minimizes wasted space but creates small fragments. Worse fit leaves larger fragments but may waste more space. External fragmentation is a major challenge in all strategies. Memory compaction can solve fragmentation but adds overhead. Strategy selection depends on specific system requirements. Now that we have covered contiguous memory allocation, let's look at a few related topics. Paging, which is a non-contiguous memory allocation technique that uses fixed-size pages. Segmentation, which involves the logical division of memory into variable-sized segments. Finally, virtual memory, which extends physical memory using secondary storage. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.